All right, so in this lesson, we're actually going to be reviewing our order of operations. So before I get to what function notation is and how we're going to use it, let's talk about the order of ops. Now, we said it was GEMDOS, and the G stands for grouping symbols, the E for exponents, and then multiplication and division we know is from left to right, and adding and subtracting from left to right. So the cool thing about this lesson is it's basically review of order of operations that we learned at the beginning of the year. All we're doing is we have a new notation that we're going to learn, and notation is just how we write things. So, like for example, in Algebra 1 we write our fractions for division, okay? That's notation. So the thing about functions, and we're going to talk more about the vocab later with domain and range, where all the x's are the domain and all the y's are range. Another way we can talk about the x's and the y's are inputs and outputs. So we're going to get to that a little bit further, but I do want to talk about input and output today. So if we have y equals 2x minus 8, this is variable notation, or where we have both variables, the x and the y, written out. Now, the function notation, instead of writing y, we say function of x, or f of x, equals 2x minus 8. So when we say this is red, we're talking about the f of x part, and this is not multiplication, okay? It's red, f of x. And this means, or I guess you could say it means, function of x, okay? And now again, just make a quick note that this, we're used to seeing numbers or letters next to parentheses meaning multiplication. But in this case, and that's why we learn this notation, because you're going to be using it a lot, especially in Algebra 2 and pre-calc and beyond. This f of x is not multiplication, okay? Basically, notation, it's just another way of writing things. And in fact, all you're doing is replacing the y with this f of x. So essentially, the thing you need to understand is y equals f of x, and you're going to be using that a lot, especially in, like I said, Algebra 2 and pre-calc and everything beyond that. But just know that these are equivalent. And the x is actually the input that we're going to plug in, okay? And then the y is the output. So in other words, it's the answer we get after we use the order of operations. So we're going to say it's the final value, okay? And then of course later on we're going to get to all the vocab for functions and relations, and we're going to talk more about not just input for x, but domains, and then not just output for y's, but range, okay? So the nice thing is, all we're doing is to evaluate this function for a specific value, and this specific value right here, that's what's inside the f of x, okay? So the specific value is always inside. So like for example, on 2a, g of 1, we're going to plug in 1 for the x, but we just substitute in that value for x, okay? So for example, let's just go ahead and do 2 together. G of x equals 3x minus 8. We could write it y equals 3x minus 8. And on part A, we could write this when it says g of 1. We could write it as, okay, well we know it's part A. We know that x is 1. So again, the specific value is 1, okay? So this time we're plugging in 1 for x. So all we do, and 3x means 3 times x, so we have 3 times 1 minus 8. Well, we just follow the order of operations. 3 times 1, we get 3 minus 8. Now we can do the subtraction, and that's negative 5. So we're not solving equations. All we're doing is plugging in and then doing the order of operations. That's it. And the nice thing about this notation, when we write g of x equals 3x minus 8, notice we can do multiple different problems. So like in B, this time we know x is negative 3. So instead of plugging in 1 like part A, we're still going to use the same equation, or basically it's like a formula almost. And this time we're plugging in negative 3 for x. So we have 3 times negative 3 minus 8. Again, order of operations, we do the multiplication first. So 3 times negative 3 is negative 9 minus 8, and we know that that is negative 17. Okay. So the input, when we plug in other words, input means what we plug in. If the input is negative 3, the output is negative 17. Okay. And we're going to talk more about this later. In fact, we can even get points like x comma y, which we're going to start graphing too. So then for part C, we're going to plug in x is 0 this time, but we're still going to use that 3x minus 8, but this time we're plugging in the input of 0. So it becomes 3 times 0 minus 8. Well, we know multiplication, 3 times 0 is 0 minus 8 is just negative 8. Okay. Now, I actually want to do number 3 instead of number 4. I was going to do all the evens, but let's do review of fractions, okay? So for problem A, we know x is negative 3 because that's what's the value, the specific value in the parentheses or the input, okay? So for the equation, we just plug it in for x, so it becomes 2/3 times negative 3 minus 1. And if you remember, anytime you multiply a fraction times a whole number, we just put the whole number over 1, okay? And then we could divide first. I could divide 3 into negative 3, and we know that it's negative 1. But, well, okay, let's go ahead and do that since I already did it. And then 2 times negative 1 is negative 2. And since the 3's divide out, we don't need the 1 in the denominator. I'm not even going to write the negative 2 as a fraction. And then we just copy the minus 1. And when we know final order of operations, negative 2 minus 1 is negative 3. And we're done. Okay. I love plugging in 0 because basically anytime the input or the x value is 0, whatever you multiply by 0 is going to be 0, right? So if we do 2/3 times 0 minus 1, because we're just plugging in the input of 0 in for x, I don't even have to worry about whole numbers and fractions. I just know a fraction times 0 is just like any number times 0. So that equals 0, and then I have the minus 1, so the overall answer is negative 1. Okay. So part C, it tells us the input is 9, so we know we're going to plug in 9 for x. So we have 2/3 times 9 minus 1. Now remember, anytime we multiply a fraction times a whole number, you put the whole number over 1. I'm going to divide the denominator into the numerator, so 3 goes into 9 3 times. The denominators are 1, so we don't need to worry about a fraction anymore. So let's just multiply the numerators. 2 times 3 is 6. And again, like I said, we don't need to put it over 1 because it's a whole number. Minus 1, and we just finish the subtraction. It equals 5. So again, when x or the input is 9, the y or the output is 5. And we're going to talk more about this in class. Okay. Number 6, this actually reviews a big topic that we reviewed at the beginning with order of operations in Unit 1. Anytime there's a negative in front of parentheses, variables, anything, remember we said you had to rewrite it as negative 1 times, and then whatever's in front of there. So instead, in this case, it's x squared, and then plus 6x minus 4. I had a lot of Algebra 2 honors students that still struggled with this. So if you master this now in Algebra 1, it's going to be so much easier for you down the road. And the reason why this is so important is because we know in the order of operations, exponents come before multiplication when we know what x is. And the reason why we separate it, anytime you have a coefficient, like this negative means -1, it's being multiplied by what comes next. Well, what comes next is an exponent. Too many people will make the mistake of multiplying the -1 and then squaring, even though they know you're supposed to do the exponent before you multiply. So that's the biggest mistake that I see. That's why I have you, it's kind of like anytime you see this negative, think emergency, I got to rewrite it so that when I plug in, like say for A, I know the input is -3, so x equals -3. I'm going to plug it in to this equation so that it's -1 times the -3 is squared plus 6 times -3 minus 4. Okay. I'm probably going to use some extra room because I'm running out of room since I write big. And this is a longer problem. So we know by order of operations we have to square the -3, but we can't multiply by -1 yet because we know exponents come before multiplication. Now we know since addition comes later, I can go ahead and multiply the 6 and the -3 since the plus is a lower priority operation. Okay, so here I'm just going to write this so I don't bleed into part B. Okay, so like I said, I can't multiply by -1 yet, so I'm going to copy that down. And then -3 squared. This is also a mistake I saw a lot of in Unit 1. Remember, this is -3 times -3, which becomes a positive 9, because we know a negative times a negative is positive. And then plus, well, 6 times -3 is -18, and then we copy the minus 4. Now we can do the multiplication. So we get -9 plus -18 minus 4. Well, -9 minus 18 is -27 minus 4. So that's going to be oh gosh, I just blanked out. I heard a sound outside. 31. There we go. Okay, so that's for part A. I actually want you to do part B and part C on your own. So pause the video and I want you to do 1, 4, 5, and then 6, B and C. And then see if you're this side. I want to review like 9 and 10. We already did fractions in the last page. So just remember when you plug in, you put the whole number over 1. Okay. Number 9, again, remember, order of operations, since this 2x squared means 2 times x squared, and if you want to, go ahead and write that out. 2 times x squared plus 4x minus 9. You got to remember, exponents come before multiplication, so you have to square the input, or what the x value is, before you multiply by 2. Again, similar to that -1, in problem number 6, that's the biggest mistake that I see. So in A, we know the input is -8. So we know x is -8. So when we plug that in, it looks like 2 times -8 squared plus 4 times -8 minus 9. And again, I'm going to use a sticky note because I'm running out of room. So again, we square the -8 first, so it becomes 2 times, and the -8 times -8 is a positive 64, because a negative times a negative is positive, plus 4 times -8 is -32, and then minus 9. Okay. Now we're going to go ahead and multiply 2 times 64. Well, 2 times 4 is 8, 2 times 6 is 12, so it's 128. And then we still have the plus negative 32, oops. So negative 32 and then minus 9. And then if you use your calculator, which basically 128 plus 32 is going to be 128 minus 32, and there's more positives. 8 minus 2 is 6, and then I think of it as 12 minus 3 is 9. So it's 96 minus 9. We still bring that down. And then when I subtract 9, I'm going to subtract 10 and then add 1. So if I subtract 10, it's 86, but add 1, so it's going to be 87, since minus 9 is 1 less, or sorry, 1 more than minus 10, okay? So I want you to go ahead and try parts B and C on number 9, as well as 7 and 8. Now I want to look at number 10, part A, because then I'm going to have you try B and C on your own. The biggest thing with order of operations and absolute value is that I get students that forget you don't change the absolute value, you don't use the absolute value until you finish everything inside. So in this case, we'd have to do, and if you want to write this or rewrite it, we know it's the absolute value of x minus your x squared, and you're going to want that x squared before you subtract, but not including the subtraction. So you have to do all the stuff inside before you can take the absolute value. So the absolute value in this problem is the last step. So like in A, we know the input is 4, so we're going to plug in x is 4. So it looks like the absolute value of 4 minus 4 squared. We have to do the square, so we get the absolute value of 4 minus 16. We still have to do the subtraction without the absolute value. We can't take the absolute value yet. So this becomes the absolute value, well, 4 minus 16, there's more negatives, so it's negative 12. And then the last step, the absolute value of negative 12 is positive 12. Okay? So I want you to go ahead, pause the video, and do 7, 8, and 10B. Okay, coming back from some technical difficulties. So number 11, the first thing I notice when I see this, yes, it's a word problem, but right away, as soon as I see the function notation, the only part that the word problem does is identify the labels for the x and then the overall h of x. So basically the label for the input and the output. So if you read this with me, it says, anthropologists use the length of certain bones of human skeleton to estimate the height of the living person. One of these bones is the femur. That's your thigh bone, your upper leg bone. To estimate the height in centimeters of a female with a femur length of x, so right away I know x, or the input, tells us it's the length of the femur. The function h of x equals 61 and 41 hundredths plus 2 and 32 hundredths x can be used. So right away, I also notice that it says estimate the height in centimeters of a female. So the output, or the h of x, is the estimated or approximate height, or overall height. And remember, this is the output. Okay, the overall answer is the output. The x is the input, and since it's the length of the femur, and again, we're using centimeters because it's uniform for the whole problem A tells us that the input is 46, so we know we're going to plug in x is 46. So we're using this equation, and we have 61 and 41 hundredths plus 2 and 32 hundredths times 46. So we just use the order of operations, and we're going to multiply the So we have 61 and 41/100ths plus, and then if I use the calculator, I find out 2 and 32/100ths times 46 is 106 and 72/100ths, and then I just add that, and I get 168 and 13/100 centimeters as the output. Now, what does this mean? So again, we're using this equation to estimate the height in centimeters of a female. We knew the input was 46, so basically what does it mean? It's a female with a femur, that's the bone, of 46 centimeters, because that was our input right here, has an approximate height of 168 and 13/100 centimeters. Now, the reason why I have this card here is I'm going to give you an extra credit opportunity. And I want you to use and basically measure your femur. So basically from your hip, about the center of your hip to your knee, center of your knee, just as an approximate. So measure your femur. Basically, okay, center of your hip to the center of your knee, and this is in centimeters. And again, you're just using your best estimate. And then for biological females, we're going to use the same formula that they use here. So we're going to find h of x is the 61 and 41/100ths plus 2 and 32/100ths times, or x, which is your input, which is the measure of your femur. Okay? If you're biologically male, you're going to use h of x for your approximate height as 61 and 41/100ths plus 2 and 38/100ths x. So we know on average biological males are taller than biological females, so that's why the coefficient of x is 6/100ths bigger for the males. So what I want you to do is go ahead and figure out what your approximate height is. And I also want to know what is your height in feet and inches, and then we can do a conversion. Remember when we did converting units to turn your height in feet and inches into centimeters and see how close this approximation is, okay? And of course there's going to be some human error, because when you're trying to measure your actual femur and you're just using, you're just approximating from approximately the center of your hip to the center of your knee, there's going to be some human error involved, okay? So anyways, let's get to the last problem, which I really love these because there's no calculations. It's basically just reading a graph. And the nice thing about function notation is the input is always going to be your x, like we've been talking about, which if you look at the coordinate system, I know in middle school you guys are used to graphing points x comma y in the coordinate system, like quadrant 1 where the x's are positive and the y's are positive. Quadrant 2, the x's are negative, the y's are positive. Quadrant 3, x's are negative and the y's are negative. And quadrant 4, where the x's are positive but the y's are negative. So when we say the f of -4, well, we know the x is -4, but the f of -4 is the y. Remember in the beginning of the notes we said y is basically the same thing as f of x, or y is the output. So this curve, basically, for every x or every input, it gives a y value on the graph. So in A, just like we're used to, we know x is going to be -4. All we have to do is go to -4, and then notice to get to the red line or the curve, the f of x, I have to go up 2. Well, guess what? That gives me the y coordinate of +2. So all you're doing is reading the y coordinate to get to the red curve. Now B, we know x is 0. Okay, well, when x is 0, guess what? The red curve is right there at 0, 0, or the origin, so the y is also 0. Okay. Now for C, same kind of thing. We know the input, or the x, is 2, right? Because this is what we've been doing. So we go to positive 2, but we have to get to the red line, we have to go down 2. Well, guess what? The y value is negative 2, so that's why the output is negative 2. And then on D, well, we know the input is 5, so when x is 5, we have to go down 1 to get to the red curve, so we know the y value is negative 1. Essentially, you can read this function notation and you can actually rewrite it as a point in the x comma y coordinates. So when I see f of negative 4 equals 2, I could rewrite this as the point negative 4 comma 2. And the reason why I'm telling you this is you'll see it in Algebra 2, pre-calc, college algebra. You'll see these things, especially if you want to get into the honors math. And again, it's just notation that you're getting comfortable with. So bring any questions that you're unclear about or didn't make any sense to class, and I will see you guys soon. And I'm excited to see how many people do the extra credit opportunity.